Lean Six Sigma is both a concept and a systematic improvement process that aims to help businesses cut down on waste, boost productivity, and get rid of everything that doesn't provide value to the company. Lean Six Sigma is a methodology that leverages the strengths of both the Lean and Six Sigma approaches to increase quality control, company growth, and supply chain efficiency. Simplifying, improving, and streamlining the supply chain can help businesses boost revenue and save expenses, particularly in the manufacturing industry. Nonetheless, despite LSS's many advantages, businesses frequently face difficulties when trying to put it into practice. For example, it is estimated that over 70% of major organizational reform efforts fail. In order to overcome this obstacle, it is crucial to create a reliable decision approach for assessing the critical elements of a fruitful rollout. The application of LSS in the production supply chain has been the subject of a number of research. In order to increase operational efficiency while also contributing to environmental and social sustainability, Rathai et al. Created and tested a framework for adopting LSS. When it comes to reducing waste in the production of transmission components for automobiles, Guilleria et al. Proposed a feasible strategy for doing so by employing the LSS tool. This study by Singh et al. Aimed to identify and rank the most important factors that contribute to the successful adoption of environmental LSS by SMEs. The research of Caswin and Rathai centered on determining and modeling the factors that help or hinder Indian businesses' efforts to adopt LSS. Evidence was provided by Kalawol et al. Showing how DMAIC, an LSS tool, encourages double-loop learning to decrease pre-consumption food waste and loss. Using data from a genuine manufacturing company in Bangladesh, Ali et al. Created a framework to pinpoint the obstacles to LSS adoption in production chains. Less studies have been conducted that highlight the most important considerations for introducing LSS into manufacturing supply chains as a means of bringing about organizational transformation, despite the many that have been published on the topic. Furthermore, businesses require a systematic method for addressing and managing change in order to optimize supply chain processes. Thus, it is crucial to benchmark performance metrics and savings across manufacturing supply chain networks by building an effective decision technique for examining the critical criteria for successful LSS deployment. Inefficient technologies, unsustainable consumption patterns, substantial process variation, production faults, and waste generation, notably from plastic products, describe the backdrop of the Nigerian industrial supply chain. These difficulties can be viewed as openings through which LSS adoption and innovation can bring about the hoped-for benefits in terms of change management. Finally, LSS allows businesses to improve their supply chain processes. Yet, LSS deployment is a difficult organizational transformation effort that calls for an efficient decision approach to analyze critical elements in order to succeed. So, more study is required to establish a clear strategy for dealing with and controlling change in order to enhance processes and supply chain networks.